Sending a spacecraft to explore far-off places in the solar system is cool, but you know what's even cooler? Sending spacecraft to explore outside the solar system. It's new terrain for human-made objects, and we've only done it twice, but in a series of papers published this week in the journal Nature Astronomy, scientists shared the first results from Voyager 2, the second spacecraft to break out of the solar system, so we're starting to learn more about what's out there. In 1977, NASA launched the twin Voyager spacecrafts on a daring mission to explore the outer solar system. Both flew by Jupiter and Saturn a few years later, but then, as Voyager 2 headed for Uranus and Neptune, Voyager 1 veered away from the planets and toward interstellar space. Back in 2012, it became the first artificial object to cross the heliopause. That's the boundary where the sun's solar wind plows into the gas and dust of interstellar space. It's on the order of hundreds of thousands of kilometers thick, and it's one way astronomers define the edge of the solar system. Voyager 1 made all sorts of measurements about what that boundary area was like, but it was hard for scientists to figure out how much those measurements said about the entire heliopause as opposed to that one spot where it crossed. That's what made it such a big deal when NASA announced last November that Voyager 2 had also reached the heliopause. Now, a year later, researchers have started to compare what the two Voyagers saw. Voyager 2 has been able to collect even more data than its sibling because its instruments are in better condition. The new data tells us that both missions crossed the heliopause at about the same distance, just over 18 billion kilometers for Voyager 1 and just under that for Voyager 2. That's an important data point because scientists debate how spherical the heliosphere or area of the sun's influence is. At least at these two locations, it seems pretty symmetric. But Voyager 2 found the boundary layer at the heliopause to be much thinner. That might be because the sun's activity is currently near a minimum compared to the solar maximum that happened around the time Voyager 1 flew through. So maybe there was less of a buffer between the solar system and interstellar space when the second probe passed through. Or maybe it suggests something more fundamental about the structure of the heliopause. After all, the two probes did spot some differences that aren't easily explained by the sun's activity. Like Voyager 1 found patches where plasma from interstellar space was leaking through, something Voyager 2 didn't see at all. It turns out 2 data points is a heck of a lot better than 1, but also still not that many. To really understand what's going on, we're gonna need more spacecraft to study different locations, but that's a 40-year journey, so I wouldn't hold your breath just yet. In the meantime, let's look out past Voyager to a record-setting black hole. The most common black holes astronomers find are usually 5 to 15 times more massive than the sun, while so-called supermassive ones can be literally billions of times more massive than that. But those aren't the only black holes out there. Physics suggests that stellar mass black holes can be as little as half the size we're used to seeing. The only problem is these little ones can be tricky to observe. They're just tiny little black holes. They're black holes. It's hard to see them. Small black holes pull in less material than bigger ones, and if they're not feasting on anything, black holes emit basically nothing. Hence the whole black part. But a paper published last week in the journal Science suggests a new way of finding these little runts. And as is often the case with black holes, scientists went looking for their effect on stuff around them. See, many stars in the galaxy are binary, meaning they're paired with another object and orbit a shared center of mass. If their orbit is aligned just right, we can see these stars move toward and away from the Earth as they circle that center of mass. That forward and backward motion causes their light to alternate between a little too red and a little too blue as their light waves get stretched and compressed. If they know the mass of the big star and the time it takes to orbit, astronomers can work out how much the second object must weigh. Then it's time to pull out the telescope. If the second object should weigh as much as a star, but there's no star in sight, there's a good chance It's a black hole. Astronomers in this recent study went through an archive of old observations looking for giant stars that seem to be changing color in this predictable pattern. Then they narrowed down the search to stars that seemed to be orbiting invisible companions. And they discovered what may be the smallest known black hole. It most likely weighs just 3.3 times the mass of the Sun, and it could be as little as 2.6 times the mass of the Sun. If so, that would put it at just a hair over the theoretical limit of around 2.5. Basically, it's just a little baby black hole. It is more massive than our entire solar system, but still. Even better, the method scientists used to make this discovery gives us a whole new way to look for tiny black holes in our galaxy. Now, when I said record-setting black hole, you probably didn't think I meant the tiniest ever, and I'm sure I'll be back soon with more of the biggest, baddest stuff in the universe, but for now, it's good to give a win to the little guys. Thanks for watching this episode of SciShow Space, produced by us here at Complexly. We produce over a dozen shows, including Ars Poetica, which is a co-production between Complexly, the Poetry Foundation, and poet Paige Lewis. Ars Poetica brings you a new poem 3 times per week, read by poets and writers and artists, and sometimes unexpected yet familiar voices like my own. I got to do one for Halloween, and so of course I chose The Raven by Edgar Allan Poe. It's really fun to read, and it sounds like it's a creepy poem, but actually it's just about how grief is inescapable. So really just bring you up there. There's a link in the description.